Hello everyone and welcome to VisualCAMc for Onshape. And this video we're going to be doing our quick start guide part. And as you can see, I got the part displayed on the screen. And if you go over to the Part Studio tab, you'll see the Onshape part as well. And we've got three tabs here at the bottom. We got a quick start tab, and use this to go through the quick start guide. It's a start part, has no toolpaths or anything. And then we have a done version and also a PDF version of the quick start guide itself. So let's start by talking about the VisualCAMc interface. VisualCAMc is divided into three main areas. You have your top toolbar at the top, your main toolbar. You'll have your machining browser on the left. This is where your machining job is created. Any toolpaths that you created are all listed here. And then you also have your tools tab where you can create tools, load tool libraries, things of that nature. So let's go over to, also one thing I wanted to point out is you have a preferences icon here on the machining browser. That allows you to control your color scheme for your cutting tools, your stock cut colors, your toolpath colors. You also have toolpath related preferences. And also you have post preferences, how your post files are going to be generated, the naming conventions. And then also you have system preferences. You have an autosave option. And so let's go ahead and cancel that. Now, if we move over into the main display area, you obviously have your part displayed on your screen, and you have a heads-up toolbar here at the top, and this is used for viewing and zooming, changing your view orientation. And then you also have toggle icons in the top left corner that allows you to toggle on and off various types of geometry and entities in your display window. For example, we can turn on the WCS, and as you can see, we make it smaller here. You'll see that there's two triads here. You have the WCS and Onshape's WCS, and then you have the MCS, which is your machine coordinate system in VisualCAMc. Okay, so let's go ahead and take a look at how we're going to machine this part. So we have a flat part, and we have some contour to it. So we got curves and radiuses around the edges, and we got various holes on the top. So let's go through the process of setting up this part to machine it. So we're going to start from the main toolbar at the top and work our way from left to right. So we'll start with machine, and this is the machine coordinate system of the machine tool. So currently when you first run VisualCAMc, your MCS triad will be aligned with your WCS triad. So that's by default. We don't need to change that for this part, so we're just going to pick cancel. Next, we're going to go working from left to right. We're going to select our post. You can load from over 300 predefined post processors. So we'll pick the load from defaults, and this will be your selection list for all of your post processors. By default, I have the Haas post selected right now. So let's go ahead and take a look at some of the other posts that we have. We got Fanuc posts, we got Fager posts, flash cut, all kinds of posts in here. So I'm just going to leave it set to Haas. We'll pick done, and the Haas is selected for the post processor. We'll pick close. So you see we got the Haas post is displayed. And also now in the release version of VisualCAMc, you can have multiple setups, and you can do indexed 4-axis and indexed 5-axis machining. So in this quick start guide, it'll be a good idea to go ahead and look at the machine and go to the machine definition tab and make sure it's set to 3-axis. So that's what we want for this part. We're going to do, actually we're just going to use 2-axis and hole machining for this part, but both 2 and 3-axis parts will be set to 3-axis on the machine type. So now we're going to move from left to right, and we'll select the stock, and we're going to use a part box stock. And by default, it tells you the dimensions of the part bounds dimensions of your part. And we're going to go ahead and we're going to add some material to each axis of the part. Now, one thing that you'll notice that the values that I'm entering here may not be the exact values that you see in the Quick Start Guide PDF document, but we're doing the same procedures using the same toolpath, same part and everything. So you can use the values you see here that I'm entering, or you can use the values that's in the actual Quick Start Guide. So we're going to add some offset to the stock, and then we're going to pick Save, so that you see that we have the stock is now defined as a part box stock, and you can, your stock should be displayed on the screen. If it's not, you can use these toggles to turn various parts of your display on and off. Okay, so let's go ahead now, and we have setup 1 listed. When you first open up a part, there'll always be a setup 1 by default, and setup 1 is aligned with the world coordinate system in Onshape. The machine defines the machine coordinate axes and orientation, and the setup will define where on the part you're setting up to machine. For example, we're going to machine the top of this part, but if your part had features on the side or on the bottom, you could edit this setup so that your coordinates are pointing in the direction that you want to machine. So we don't need to change that, so we'll leave that set to setup 1. So let's move on to the left. Let's create a work 0, and the work 0 dialog is displayed. Now this is where on your machine tool that you're going to program your 0 point. So we're going to use this back left corner of the stock as our program 0 point. So we're going to pick Set to Stock Box, we're going to pick Highest Z, and we're going to pick Southwest. And that'll move, you'll see that your MCS triad is now moved from here over to here. By default, when you first displayed this, it moved it over this corner by default, but then we moved it over using these selections to the back left corner. So now we'll pick Save, and you'll see that we have the work 0 on the back left corner. So how are we going to machine this? Since our stock is higher than our part, we're going to want to face this down to our part face. So let's go ahead and do a 2.5 axis facing operation. And what do we want to use to control the facing operation? So in VisualCAMc, you can use your mouse to select machining regions. If you use the left mouse button, it selects one edge. If you use the space bar, that unselects the edge. If you use the right mouse button, it'll select a chain of edges. So that's what we want to do. So we have our geometry selected. For our tool, we don't have any tools set up yet, so let's go ahead and pick the Create Tool button. For this facing operation, let's go ahead and create a face tool, and we'll set the dimensions of the tool. We'll set the tool diameter to 1 inch, set the tool length to 3, the shoulder length to 2.5, flute length is 0.375 for our facing tool. So for the shank diameter, we'll just leave that set. We'll set it to a high-speed steel, and we'll just put a comment in here, my first tool. And so we got all the tool parameters set. We'll go ahead and pick Save, and you'll see that it adds the face mill tool to your operation. Now we'll go ahead, you'll notice that each operation is divided into tabbed areas. We have the select tool tab, now we have the feeds and speeds tab. You can set your feeds and speeds for this particular operation. We'll leave these set to the defaults for now. We'll pick the clearance plane tab. The clearance plane is where the tool will retract to when it goes to cut in another location. It'll retract to this plane. So we're going to set it to automatics, where it automatically determines where that clearance plane is. You have other options here if you want to determine by the part or actually enter an absolute value. So for cut transfer method, this is where is the tool going to transfer when it goes from one cut to another. We're going to leave it set to the clearance plane. And let's go to the parameter section. Now the parameter section of each toolpath operation dialog is divided into subtabs, and each operation will have different parameters. So for the facing operation, we're going to set the tolerance to 1000. We'll set the stock to 0. In 2.5 axis, stock refers to in the X and the Y, so we don't have any sidewalls on this face, so we're just going to leave that set to 0, and we're going to use island offset cuts. We're going to use 25% step over. That should be fine. For the cut levels tab, okay, location of cut geometry. Ask yourself, where is the geometry that you selected in relation to your cut? So the geometry we selected is at the top edge of the face, and that's where we want to cut. So it's at the bottom of our cut. So we're cutting down, and it's going to stop here. So that's the bottom. And for the total cut depth, we'll leave that set. Actually, we added some offset to 0.1. So we'll set the total cut depth to 0.1. That'll be the top of our stock. And then we can add a rough depth per cut of 0.05, and that'll give us 2 levels. And that looks pretty good for the entry and exit. We'll go ahead and set lines and arcs. You can set the approach motion, engage motion for the entry, and you can also set the retract motion and departure motion for exit. So for entry, we'll go ahead and accept the default values. We'll apply the entry and exit at each cut level because we're going to have 2 levels. For the exit, we'll leave those set to the defaults. Let's go to the advanced tab. And we're going to have some arcs. So let's go ahead and do some arc fitting. Now for the arc fitting, it's recommended that you set this to 2 times your global tolerance. So in the general tab, we have a global tolerance of 1000. So we're going to set the arc fitting to 2000s. And we can also, let's generate this, and then we'll make some changes after we generate it so you can see the difference. Let's go ahead and generate. So here is our toolpath. You'll see that we have 2 levels, and our offset of 25% of our face mill tool. And let's go ahead and do a simulation of this. That was pretty fast. Let's go ahead and slow that down a little bit. And let's go ahead and run it. So this is our first level. Now I'll go down to our second level. There we go. So there's our simulation of our facing operation. And these buttons up here, you can, just like an 8-track, well, if you remember the 8-track tape players, usually they used to have a play and a stop and to end. It's the same deal here. Play starts the simulation. You can step through the simulation one motion at a time, as you can see there. Or you can pause the simulation and go directly to the end. It'll show you the simulation as it appears at the end of the last cut. Then it has a stop, and then you have a simulation speed, a simulation progress bar, and the exit button. Let's go ahead and exit out of that. Okay, so here's our facing operation. We have the cut in process cut material displayed in the background here, and you can control that by your stock button. You can toggle that on and off. So let's go ahead and take a look at your facing operation again. And let's see if we can make some changes here. So we'll perform cut rounding. So it's going to put rounded fillets on these sharp edges so that there's no stop and starts for our machine tool. It just makes it a little bit easier on the machine tool as you cut. Plus you can increase the feed rates when you have all radiuses to cut. And then we'll use smooth cut connections. Let's go ahead and generate that and see if it looks any differently. Okay. So you see now it added smooth cut connections on here. Now one thing I do want to check is in our preferences, in our toolpath preferences, we have this option here, output arcs as linear segments. Now if your controller can cut arc motions, it's better to cut arc motions because it's faster, less G-code to process, and it's easier on your machine tool. So let's go ahead and turn this off so that we can output arc motions. We're going to save that. Then we're going to go back into our facing, and we're going to make sure that we got our perform arc fitting turned on. So let's generate. Okay, so now you see that these cut motions turned to blue. Now if you go back into the preferences dialog for the color preferences for toolpath colors, you'll see that a cut arc is a dark blue. Previously it was a light cyan, so that's just a linear cut motion. So these are all arc motions right now. So there's our facing operation. Now let's go ahead and do a profiling operation to cut the outer perimeter. So we'll go to 2.5 axis and we'll go to profiling. And for the profiling name, we'll just put outer perimeter. And for a tool, let's go ahead and create another tool. For this, we'll make it a flat end mill. And let's make this a smaller mill. Let's just say make an 1/8 inch mill. And we'll just call that 1/8 inch flat mill. And for the name, we'll call it 1/8 inch. Okay. So let's go ahead and save that. So we have another tool called flat mill 1/8 of an inch, and we're going to use that to do the perimeter profiling. Feeds and speeds, we'll let those set to the same clearance plane. Okay, profiling parameters. We're going to have our tolerance set to 1/1000. Our stock is going to be 0. Now, you can leave some stock and then come back with another profiling operation as a finishing cut. But you can also specify a total cut width and divide that width up in a step per cut. So you can do one cut to leave a certain amount and then do your finishing cut. So you can do your finishing with this and you don't have to do a second operation. But we're going to finish at 0. We're just going to do one pass all the way around it. So we're going to have a mixed cut direction. So for the curves that we have selected, you notice that the edges that we had selected from the facing operation are still highlighted. So we want to go ahead and use those. So we're going to use inside outside for closed curves, and we're going to machine on the outside. Now optionally you could select the determine using 3D model and it would figure out which side is the part and which side is not, and it would do that for you. So for the cut width, we're going to leave these set at 0. So for the cut levels, again, where is our cut geometry? It's at the top. We're starting our cut here and we're cutting down. So the geometry is at the top of the cut. So the total cut width, I happen to know that this part is 157 thick, and we're going to go ahead and do this in 0.05 levels. So it should be about 3 or 4 levels. And we don't need sorting, entry and exit. We're going to use a ramp entry. A long path means it's going to ramp down and then start your cut. So we're going to set the angle, say at 5 degrees, and the height, and we'll set that 0.1. And you'll see that it'll probably ramp almost halfway around the part. Let's go ahead and see how it looks. And we'll go ahead and set the ramp at each cut level. And we'll go ahead and set an overlap distance of 0.1. And overlap means that when it starts its cut, and then when it gets down around to the last, at the end of the cut, it's going to overlap that start point to get a clean finish on the sidewalls. So for advanced, we're going to do arc fitting again, and we'll go ahead and generate this now. Okay, so you see here, this is our ramp motion, our 5-degree ramp, and it's ramping in at each cut level. So it's got, looks like it's got 5 cut levels. And let's go ahead and double check one thing on the general tab. Okay, so we're going to do a mixed cut direction. Let's go ahead and see what this looks like with just a climb cut direction. So you see that with the climb, it all comes to in the same direction. So let's go ahead and leave it at that, and let's go ahead and simulate this. Just right click on the operation, pick simulate, and you see our ramp motion, our exit, and our re-entry for each level. Ramp motion, exit, entry, ramp, and one more level. Okay, so there's our perimeter cut, and let's go ahead and speed this up a little bit and just run it again real quick. So there's our outer perimeter cut. We'll go ahead and pick exit. Okay, so we've got a finishing operation on the top, a facing operation on the top, and a profiling operation on the outer perimeter. So now let's go ahead and drill some of these holes. We're going to go ahead and pick the holes menu, pick drill, and we're going to put 157 drill, and we're going to create a drill tool, and I happen to know that this drill is 0.157 diameter, and make our diameter, and it's a pretty good idea to set your tool diameter and the shank diameter to the same value. And then also change that. Okay, so let's go ahead and save our drill tool. Now, feed and speed, since we're drilling, we want to slow this down, so let's bring this down to 190. And for all these, we'll set these to 15. And then for the clearance, we're going to use the same clearance plane. And for the parameters, what type of drill are we going to drill? You have a number of different drill types you can select. And from standard drill to a deep drill, a countersink drill, a brake chip. Deep and brake chip are basically the same. If you set it to deep drill, it enables this additional option for step increment, so that controls your pecking depth. And so we'll go ahead and let it set to deep drill. We'll set a 0.1 for a pecking depth. Where's our, for the drill depth, we know it's going to be 0.157 deep. We're going to add our drill tip to the depth, make sure it's a through hole. Where is our geometry? Well, we don't want the geometry from our profiling operation selected, so we're going to press the space bar to deselect the geometry, and then we're going to pick our drill holes that we want to drill. And the location of those holes are at the top. So the drill is going to start here, and it's going to work its way to the depth of 0.157. And we'll give it some dwell time. Our approach distance will be 0.1, so it's going to come from our clearance plane down to our approach distance, and then it's going to start the spindle speed and drill. So let's go ahead, and for sorting, you can also sort your drilling operations. For you, if you have a lot of holes, this really saves you some time. Let's leave it to no sort now, and then we'll show you the difference. So there's our drilling operation. You'll see that it passes all the way through. And let's go ahead and do a simulation. Let's go ahead and slow this down a little bit and just pick play. You see the pecking movement there? So it goes all the way through. And then let's also exit out of that. And what you can do is you can sort these holes. Let's say minimum distance sort, and you can tell it where to start. And let's generate that. And you'll see right now, you'll see that we're traversing across here, and that's wasting time. So let's regenerate that, and you'll see that it's reordered the holes so they're a lot closer together, and there's no traversing of the tool. So let's go ahead and simulate that again. Okay, so there's our three operations. We have a facing, outer perimeter, and a drilling operation. And let's go. One thing I did want to show you before we go ahead and post this. We created our cutting tools while we were in the operations. You could go over to the Tools tab, and you can create your operations here. Now this tab also has a lot of other options. If you had a predefined tool library, you can load that tool library. As you can see, I had one set here, and we can go ahead and get rid of the tool library. Let's get rid of that one. So we're at the default. Now, the tools that we created, you can go ahead and save these to a library so that you can use them in the future. So those are a number of different things you can do from the Tools tab. So let's go ahead and post our operations. We can post one or more operation just by holding down the Control key and selecting multiple operations, or you can just go ahead and select the setup, or you can select the machining job and post the entire job. So we're going to select the setup, and we're going to pick post. And it created our post file and downloaded it for us. So let's go ahead and open that and bring that over. You'll see that here is our G code for the Haas controller. And you notice on my first tool, there's my first tool comment. And here is the G code for all of the operations. Here's where the drilling starts. And if we go up, you should see where our outer perimeter profiling starts. And then also our facing operation starts. Well, that's it for the Quick Start Guide. Stay tuned for more videos on the release version of VisualCAMc for Onshape.